Hello everyone. Today we are going to give you quick guidelines on what data is required to make a blower selection and what to consider when selecting a low pressure blower for your application. We will begin with the data required to make the right blower selection. First criteria is airflow. Your required airflow narrows the blower selection to the most efficient 2 or 3 technologies meeting your requirements. Second criteria is discharge pressure. Depending on the application, a well-defined minimum and maximum discharge pressure helps selecting the most efficient blower technology meeting your pressure requirements. Third is inlet pressure or elevation. A blower basically compresses air to increase its pressure downstream of the blower discharge. The work required by any blower technology depends on the inlet pressure of the air sucked by the blower element. When a blower is sucking air from the blower room, ambient pressure is required to have the right selection. Ambient pressure can also be obtained from the blower location elevation above sea level. Fourth criteria is ambient temperature and relative humidity. Air temperature and relative humidity affect the performance of any blower technology. A blower performance may change dramatically during different seasons. Therefore, when selecting a blower, it would be very helpful to provide the minimum and maximum air temperature and relative humidity during summer and winter seasons to make sure a blower meets the aeration requirement throughout the whole year. The fifth criteria is footprint, the available space. If available footprint is known at the time you are making a blower selection, it would save a lot of time during the detailed engineering design. Knowing the available footprint may limit the blower selection to a few technologies that can fit the available space. Providing integrated components like starter, VFD, or controller can also help fitting blowers within a limited blower room. Now that we have all our process data to make a blower selection, we will provide a quick guideline on the options to consider when selecting the blower. First option is fixed speed or variable speed. A blower motor can be a fixed speed or variable speed motor. Depending on the application, if the operator or design engineer expects his application to require variable airflow and discharge pressure during the aeration process, it would be very efficient to consider a variable speed motor with a variable speed drive to produce the exact amount of airflow required for his process. Otherwise, a fixed speed motor can be considered, and blower would be running at max speed all the time. The second option is inlet flange. Blowers usually draw a large amount of air. If drawing this air locally from within the blower room, there must be enough ventilation to make sure enough air available for the blowers. In this case, the blower room would be open to the outside during the whole year, including winter, and therefore may require the operator to wear winter clothes to get to the blower room, especially during cold Canadian winter season. To avoid such a requirement and for heated blower rooms, blowers can draw air from the outside through a pipe or duct. For this, blowers should be equipped with a flanged inlet or should have a provision for ducting connection to the inlet over. Third criteria is sound enclosure. Blowers are usually noisy machines. Most worldwide standards require operators to wear ear protection when exposed to noise that equals or exceeds 85 dBA. To avoid such requirement, every blower should be installed in a sound enclosure to reduce the noise to less than 80 dBA. Blower and enclosure should also be equipped with inlet and discharge silencer to make sure to reach an 80 dBA noise level. Fourth is the controller. Blowers can be controlled locally or remotely. For local control and monitoring, selector switches, push buttons, and indication lights can be used, which offers very limited control and monitoring capabilities. Integrated controllers, PLC and HMIs, provide additional control and monitoring flexibility as well as communication with remote control systems. The fifth option is monitoring instrumentation. For a healthy blower operation, it is very important to be able to monitor some critical data of different components. Some of this data are the inlet filter discharge pressure to find out when the filter should be replaced, motor winding temperature, oil temperature and pressure, as well as discharge temperature. It is very important to make sure that the selected blower has all these integrated instruments to make sure the blower is protected and always monitored. As we always say, it is strongly recommended when designing a new project to request a blower selection from a manufacturer who has all blower technologies to make sure you're getting the most suitable technology for your application. Thank you very much for watching this video. Please don't forget to like and subscribe. For questions, please click on the link in the description below. We will be happy to answer you. See you next time.